Welcome to APRA Society online classes. My name is Fani Kumar and I am working as a teacher in AP Residential School Boys, Appalrajgooda, West Godavari district. In this video, I want to discuss about the lesson Fun with Magnets. Let's go into the details. Before going into the lesson, let's take some examples in our daily life. If you are at home, please observe the refrigerator. There are some stickers attached to that refrigerator. If you observe those stickers, you will recognize that those stickers have magnets. And if you observe any credit card or debit card, you can observe the black color strip beside the credit card. This black color strip contains the magnetic field. And also if you observe motor in your home, that motor contains magnets. And if you observe mobile phones, this mobile phone contains speakers, and those speakers contain magnets. And if you observe fan in our home, those fan contains magnets. So in this way, we are using magnets in our daily life without paying much concentration on it. So let's go into the details of this lesson. First of all, we have to know how the magnets are discovered in our human life. So around 2005 years ago, there is a shepherd and his name is Magnus. One day he was rearing his goats. Then after passing some time, he was tired and wanted to take rest. Then he slept on the rock which was on the hill. Then after passing some time, he woke up and he realized that his shoes, his iron capped stick, that means his stick has iron cap, and his shoes are iron nailed. And these iron nailed shoe and this iron capped stick stuck onto that rock. Then he's wondered and he told this incident to his neighbors. His neighbors came and they are also wondered, and later they found that the rock is not only attracting the iron capped stick and iron nailed shoe, but also attracting the iron pieces and some other objects. Then it was later named as magnetism. Later this property is now named as magnetism on the remembrance of the shepherd named Magnus, and this area is Magnesia, and this area is known as Magnesia, and it was in Greek. So on the remembrance of these names, this property is named as magnetism. Let's come to the next topic, that is different types of magnets. Magnets are of different types, and example for the magnet is this is Bohr magnet, and this is U-shaped magnet, and this is cylindrical magnet, and this is round magnet. So in this way we can observe different types of magnets in our human life. So Bohr magnet, horseshoe magnet, U-shaped magnet, cylindrical magnet. And horseshoe magnet means it looks like this. This is the horseshoe magnet. And U-shaped magnet means it looks like this. It looks like the English letter U. Okay. Bohr magnet means it looks like this one. Bohr magnet. It looks like a bar. Okay. Next, cylindrical magnet means it looks like a cylinder. So this is cylindrical magnet. So we can observe all these magnets in our human life. But magnets are of two types. First one is natural magnet and second one is artificial magnet. Natural magnet and artificial magnet. That means magnets which are occur in our nature are known as natural magnets, and magnets which are made by us are known as artificial magnets. Okay. And material may be classified into two types, that is magnetic materials and non-magnetic materials. Magnetic material and non-magnetic materials. Magnetic material and non-magnetic materials. Magnetic material means the materials which are attracted by the magnet are known as magnetic material, and when coming to non-magnetic materials, the materials which are not attracted by the magnet are called non-magnetic materials. Let's go into the details. Let's take this iron pin, and this iron pin is attracted by this magnet. So this iron pin is known as magnetic substance or magnetic material. And let's take this plastic pipe, and this plastic pipe is not attracted by this magnet, so this plastic is known as non-magnetic material. So in this way we can classify magnetic materials and non-magnetic materials. So magnetic materials example means these are iron, cobalt, nickel. These are all called magnetic materials. And non-magnetic material means plastic, paper, wood. These are all called non-magnetic materials. Okay, and let's now into the another topic. Those are called magnetic poles. Let's come to the next topic, that is poles of the magnet. Poles of the magnet. So to understand this concept, let's do one activity. Take some iron fillings and take one bar magnet and roll this bar magnet in the iron fillings. Then observe. You can observe that iron fillings are attracted by this magnet at these 2 points. At these 2 points more than the other points. So these 2 points are named as poles. This point and this point. These 2 points are named as poles. Okay. And let's observe with another magnet, and take one bar magnet and roll it in the iron fillings. Then you can observe that iron fillings are attracted by the magnet at 2 points more when compared to other points. So these 2 points are named as poles. So this is one pole and this is another pole. So these 2 points magnetic strength is more when compared to other points. So these 2 points are named as poles. In this way we can define poles of the magnet is the points on the magnet at which the magnetic strength is more are called poles. That means if you take the bar magnet, at this point magnetic field strength is more. So these 2 points are called pole. These 2 points are called poles, and first one is north pole and another one is south pole. Okay. And next another topic is attractive property of magnet. Attractive property. To understand this, let's do one activity. So let's take an example for the attractive property of the magnet. So this is the north pole of the bar magnet and this is the north pole of the U-shaped magnet. So let's see what happens if north pole of the bar magnet come nearer to the north pole of the another magnet. So please watch. So north pole is not attracted by the north pole and this north pole is attracted by the south pole. So you can say that unlike poles attract each other. That means south pole and north pole. Okay. So in the same way, if you take the south pole of the bar magnet nearer to the U-shaped magnet, so let's see what happens. So this south pole is attracted by the north pole. In this way we can say that unlike poles attract each other. That means south pole is attracted by north pole and north pole is attracted by south pole. This is the attractive property, and in this way we can say that unlike poles attract each other. Let's take another activity with this example, that is this is also one magnet. This is south pole of the magnet and this is north pole of the magnet, So let's see what happens. This is the North Pole. So this is the North Pole. So this is the North Pole and this is the South Pole. So what happens? Let's see. This is the North Pole. So this is the South Pole of the another magnet. So let's see what happens. This is the South Pole of one magnet and this is the North Pole of the another magnet. Let's see what happens. So in this way we can say that unlike poles attract each other. So this is the North Pole of the magnet. Let's see what happens. So if you take North Pole of the another magnet, then see what happens. It moves away, that means it repels. So North Pole of the magnet repels North Pole of the another magnet. So let's see. This is the North Pole. It repels. So North Pole repels North Pole and South Pole repels South Pole. So let's see with these two Bohr magnets, and this is the South Pole and this is the South Pole. Let's see what happens. So South Pole repels South Pole. So can you observe? South Pole repels South Pole. So if you take North Pole nearer to South Pole, it attracts. So observe. So this is the North Pole of the one of the Bohr magnet. See, this is the North Pole of the one Bohr magnet, and I will take North Pole of the another Bohr magnet. So it repel each other. So North Pole repel North Pole and South Pole repel South Pole. This is South Pole. South Pole repels South Pole. But North Pole of the Bohr magnet attracts South Pole of the magnet. Let's see. This is the South Pole and this is the North Pole. Attract each other. In this way we can say that unlike poles attract each other and like poles repel each other. Students, observe this. So this is one iron. Students, observe this. This is one iron keychain, and if you take the Bohr magnet nearer to this keychain, it attracts. Why? Because this is the iron one, and we know that magnet attracts iron objects. Okay, and how this can possible? We can say that it is possible because the magnet is surrounded by the magnetic lines of force. Can we see the magnetic lines of force around the Bohr magnet? Yes, we can see the magnetic lines of force around the Bohr magnet. Let's see how can we see the magnetic lines of force around the Bohr magnet. So for this activity you have to keep this Bohr magnet in geographical north and south directions. So this is the geographical north and this is the geographical south direction. Kept this Bohr magnet such that North Pole of the Bohr magnet shows the north direction of Earth. So just like this, and sprinkle some iron fillings around the Bohr magnet. Then you can see the result. You can see that these iron fillings are adjusted in the form of magnetic lines of force. Please watch it. You can observe that these iron fillings are adjusted in the form of magnetic lines of force, just like this. So for any magnet, magnetic lines of forces are coming from the North Pole of the magnet and entering into the South Pole of the magnet. Okay, so for this reason these magnetic lines of force attracts the iron objects, just like this. If any iron object come nearer to these magnetic lines of force, this iron piece is attracted by the magnet. So magnetic lines of force coming from the North Pole of the Bohr magnet and ends at the South Pole of the Bohr magnet, just like this. Our Earth is also a huge magnet, and this is the north direction and this is the south direction. So at the south direction of Earth there is the North Pole, and in the north direction of Earth there is South Pole. So magnetic lines of force, this is South Pole, and magnetic lines of force are also coming from the Earth
from this direction, north pole to the south pole, just like this. For this reason, our elders says don't kept your head in the north direction while sleeping. So to avoid circulatory problems, blood circulation problems, our elders says like this.
And our next topic is directive property. That means if you suspend any bar magnet with the help of thread such that the thread is tied at the center of the bar magnet, then this bar magnet always shows north and south directions of earth. Let's observe. So red color shows the north pole of the bar magnet, so it always shows the north direction of earth. So red color points towards north direction. This is the north direction. So red color points towards north. So if you disturb this magnet, it always again shows the north and south directions of earth. So I disturbed this bar magnet. Let's observe the changes. Again, this bar magnet shows the north direction. Red color means north direction of the bar magnet. It shows the north direction of earth. Let's observe. Okay. In this way, so just like this. In this way, we can say that bar magnet always shows north and south directions of earth. Using this property, magnetic compass is prepared. So magnetic compass is used to know the directions of earth. That means here this point is adjusted to the north side of the north direction of earth. So here we can't show it. So upon placing this in this position, we can observe the directions of earth using this compass.
Watch this, children. This is the magnetic compass and the point magnet. This is called point magnet. That means the magnet is pointed at its ends. Look at this end. It is in red color shaded end. It shows the north direction of earth. So coincide this point to the N. That means here is N, here is N. We have to coincide this point to N, because this point is always shows north and south directions of earth. So this point shows the north direction of earth and this point shows the south direction of earth. So you have to show this north point to the N. So just like this. In this way we can find the directions of earth. This is the north direction of earth and this is the south direction of earth, and this is the east and this is the west. In this way soldiers and sailors found their way in olden days. Nowadays very modified instruments are there, but in olden days this is the magnetic compass and this is used to know the directions of earth like this way. First of all you have to coincide this point to N, then it shows the directions of earth like this. This is the north direction of earth and this is the south direction of earth and this is the west direction of earth and this is the east direction of earth. Okay, right.
In this class we studied about first magnetic and non-magnetic materials. That means the material which are attracted by the magnets are called magnetic material and the material which are not attracted by the magnet are called non-magnetic material. And some of the examples of magnetic material are iron, cobalt, nickel, etc. And some of the non-magnetic substances are paper, wood, plastic, pen, etc. And after that we learned the poles of the magnet. That means each magnet has some points where the magnetic field strength is more. Those 2 points are known as poles. And attractive, when coming to attractive property, that means like poles repel each other, like poles repel each other. That means south pole and south pole repel each other, and north pole and north pole repel each other. And unlike poles attract each other. Unlike poles attract each other. That means north pole, south pole, north pole. These are attract each other, and like poles repel each other. And after that we learned the directive property. That means if you suspend any bar magnet freely, then it always shows the north and south directions of Earth. So here is homework for you. That means write some examples of magnetic and non-magnetic materials in your daily life. So magnetic and non-magnetic materials examples you have to write. Okay, thank you.